Good day, everyone. Again, I am Babes A. Canson, a BSED Math student presenter for today's video. And today, I am going to share my learnings about universal hyperbolic geometry and also about Apollonius and polarity. So now, let's move on to the next slide. What is hyperbolic geometry? This is a new series of presenting more logical, more general, and more beautiful approach to hyperbolic geometry, in which I learned that these are the advantages of universal hyperbolic geometry. It is simpler because lines are straight, formulas are algebraic or polynomial, and only high school algebra is needed and no calculus or transcendental functions. It is more logical since no real numbers, no axioms, and no circular hyperbolic functions. It is also more general because it works over rational numbers. Formulas extend outside this and unifies hyperbolic and elliptic or the spherical geometries. And lastly, it is more beautiful since it connects with special relativity better. Computations are faster and more accurate. Hyperbolic triangle geometry becomes a new and vibrant subject. Fascinating combinatorial aspect and richer group theory and hypergroups. And lastly, many new insight into algebraic geometry. So next slide would be the Apollonius and polarity. So I learned that Apollonius discovered the most important fact about circle. What Apollonius realized that if you have a given circle, then you automatically have a remarkable connection between point in plane and lines in the plane. This circle gives you a duality between points and line, and here's how it works. So here's our circle. And we're assuming that circle is given to us. It's fixed in a plane and it's not moving. Now choose a point in that circle. So point A is supposed to be outside the circle. What we could do here is we could look for tangents from that point to the circle. These are the lines that touches from that point to the circle just once. And there is two such tangent, one over here and one over there. And they intersect the circle into two new points which we can call beta and gamma. And those 2 points, beta and gamma, determine a line. This line, capital A, depends on this point, little a here. So if we move a point a little closer to the circle, then the line capital A moves closer also. If we move point little a farther away, then the line capital A moves closer to the diameter of the circle. I also learned about the terminology here. They say that point A is a pole of the line big A, and the line big A is the polar of a little a. I remember that polar is a little bit longer object while the pole is the smaller object. Along with this terminology, there is also a notation. We're gonna say that capital A is equal to a small a perp. So, perp means or related to perpendicularity, and that is the symbol of perp. So then, a little a is equal to big A perp, and conversely, big A is equal to little a perp. So it turns out that relation is very crucial in understanding hyperbolic geometry. And that's the end of my presentation. I hope you learned something and thank you for listening. Again, I am Babes A. Canson, your BSED Math presenter.